What is the greenhouse effect? So the greenhouse effect refers to the trapping of heat near Earth's surface by gases in the atmosphere, particularly carbon dioxide. So in greenhouse effect, carbon dioxide transmits visible sunlight and absorbs some of the outgoing infrared radiation, thereby trapping the heat. So how does it work? First, we have to learn where does carbon dioxide come from. So we are going to mention the carbon cycle. Okay, carbon dioxide can be produced when any form of carbon or a carbon-containing compound is burned in excess of oxygen, for instance. When calcium carbonate burned in an excess of oxygen, the products will be calcium oxide and carbon dioxide. Carbon dioxide can also be formed when a carbonates react with acid. So remember, when most carbonates can give off carbon dioxide when treated with acid. Okay. So the solar radiant energy received by Earth is distributed over a band of wavelengths between 100 and 5,000 nanometers. Okay, that's the solar energy received by Earth. But most of the radiant energy is concentrated in the range of 400 to 700 nanometers. So this range is actually the visible region of the spectrum. However, the the radiation emitted by Earth's surface is most of the energy is longer than, so that's received by Earth, emitted by Earth would be longer than 4,000 nanometers. That's the infrared region, okay? So why is that? Right, so the reason is Earth's surface temperature is much lower than that of the sun. So the wavelength emitted by Earth is longer than 4,000 nanometers. Now, this outgoing infrared radiation can be absorbed by water and carbon dioxide, but not nitrogen and oxygen. We'll see why, okay? We know that all molecules vibrate, okay, even at lowest temperatures. When a molecule absorbs a photon of a specific wavelength in the IR region, it's going to vibrate more energetically, okay? But to vibrate more energetically, the dipole moment of this molecule must change during the course of variation. What's the dipole moment? Remember, the dipole moment is the charge of the molecule multiplies by the distance between charges. Okay, so that's the dipole moment. Most polyatomic molecule can vibrate. Okay, and they can vibrate more than in one way. So we know water is a polar atomic molecule. It can vibrate in 3 different ways. So we can classify water as IR active because it can absorb a wavelength during the infrared region, and its dipole moment changes during the course of vibration. Carbon dioxide is also a polyatomic molecule, so it can vibrate as well. But we said that oxygen and nitrogen will not emit, will not absorb the wavelengths emitted by Earth because they are homonuclear. Okay, they are homonuclear, and there is no change in the dipole moment. So oxygen and nitrogen, they cannot have a dipole moment. Okay, no matter how far apart or close together these two atoms are. So these are IR inactive. All right. So what happens when water or carbon dioxide pick up a photon in the IR region? So when water and carbon dioxide receive a photon in the IR region, a molecule of water or carbon dioxide is raised to a higher vibrational energy level. So this asterisk means that it is a vibrationally excited molecule. Okay. So now water and carbon dioxide become energetically excited. What happens then is that they soon will lose the excess energy, either by collision with other molecules or by spontaneous emission of radiation. So these energetically excited molecules will emit its radiation spontaneously. Now, some of this radiation is emitted to outer space, but some of the radiation returns to Earth's surface. Therefore, this radiation energy is warming the Earth's surface. So that's called the greenhouse effect.